Hello and welcome to this Chapter 1 brief overview of the PowerPoint to the 16th edition of Foundations of College Chemistry. As you can see over here on the side, there's like 20 plus sides. I'm really only going to highlight what is most important in the chapter that you need to take notes on, or if you did not take notes on, you put this in your notes. So first, there's always a overview. So there's 4 sections to this chapter. This is how I would set up your notes, like an outline, put 1.1, and then the subtitle, and then each additional subtitle of each subsection of the chapter. And then just take what notes you want to take. The biggest thing is try to do more pictures. I tend to do more pictures as well. So the nature of chemistry, scientific approach, which is pretty much the scientific method, particulate nature of matter, so the physical states, solid, liquid, gas, and then classifying matter. Can we distinguish between a mixture and a pure substance? So at any time you can pause my video so you can see what's on the slide, but if there's nothing I'm really going to cover on it, then I'm going to flip through it pretty fast. So chemistry deals with composition, structure, and property reactions, and everything to do with matter. That's pretty much the purpose of chemistry, is to, discover the properties and characteristics of any matter. So matter is any object that has mass and takes up space, has mass and volume. We'll get into that with Chapter 2 with density. Thinking like a chemist, basically that gets into the scientific method. We observe, we then make a hypothesis, and we test it. So microscopic view of water we see coming from our faucets. When we talk about microscopic, we're talking about the particle diagram or the particle atomic view, so the elements involved. So water is H2O, which means it's 2 hydrogens bonded to 1 oxygen. Chemistry kind of cross-curricular, goes into a lot of other different sciences. You don't need to know that for the test. You don't need to know the fields of chemistry, but if you're interested, you can pause the video, and look up these particular ones if you're interested. So number 2, scientific approach to problem solving is called the scientific method. Here are the steps. You observe typically something that you want to know more about, or you're questioning it. You form a hypothesis. You form a test to test that hypothesis. You might modify the hypothesis as you go along, and retest until you eventually get to a theory. Okay? This would be a really good picture to put. Everything starts with an observation. We make a hypothesis, an experiment. We might, go back and redo our hypothesis, but very rarely do we get to laws. There's only like 2 or 3 laws in chemistry you're going to have to know about. There's a few more laws in physics, but a lot of times we stick with theories because that's what we know now. Okay, so a theory is a well-established hypothesis. Scientific law it's a natural phenomenon. So gravity is a natural phenomenon. We've observed it for hundreds of years. Nothing escapes gravity. If you hold something in your hand and you let go of it, it's going to fall towards the ground. But there's an exception if it's under certain conditions. We also can have now, in our current time, 0 G or 0 gravity in a lab base to where stuff will float. That's how astronauts do their training. So laws are a lot harder to come by and actually establish a law, because laws are multiple theories that have been well tested, have been accepted, by and large by the scientific community, and cross-curricularly they apply to different sciences when they become a law. All right, the particulate nature of matter. Matter is big, small, microscopic. It's always called atoms. This is actually a picture on the screen of an electronic microscope, or that could actually individually see atoms. Physical states of matter, there are three main types you need to know. Solid, it's a definite shape, definite volume, cannot be compressed, has mass, typically has a crystalline structure. Okay. I'm not going to worry about amorphous solids. They're not on my test. I didn't see anything of them on the final. Liquids, they have a definite volume but no definite shape. They also, though, cannot be compressed. So liquids will only squeeze together. They're free flowing. So they take the shape of their container, but you can only compress them so much. So once they hit a certain point, they can't be compressed. So take the example of the liquid in the glass. If you could compress that liquid down, it's only going to go down a minute amount before the glass breaks. Okay? So liquids are typically not compressible as well. And then there's gases. Gases have an infinite volume, no fixed shape, can be compressed, they can expand indefinitely. There are attractive forces that hold solids, liquids, and gases together. Attractive forces obviously are going to be strongest in solids because they have a rigid structure, a repeatable pattern. Liquids do have attractive forces, but they're a little bit weaker than solids, so they can free flow over one another. And the weakest attractive forces are in gases. Here's some common materials of solid, liquids, and gases. You're not going to have to know that. Classifying matter. Everything, and I'm going to do this in class, but everything under the umbrella of matter can be classified as two things: pure substance or a mixture. So a pure substance has a definite fixed composition. It can be an element or a compound. Okay, we can't change an element, gold, into silver. Okay, not without doing some stuff to it. And really, an atom of gold cannot change to silver. I can take gold and react it with something, but I can't change the fundamental atomic level of gold into something else. A compound, like salt, is made up of one atom of sodium and one atom of chlorine. That's still a pure substance because its chemical compounds cannot be changed unless it goes under reaction. Then you have mixtures. Mixtures are mixtures of different elements and compounds together. They can physically be taken apart. Under these mixtures, they can be homogeneous or heterogeneous. Homogeneous is uniform in appearance. Heterogeneous is where, like a pizza or a salad, you can physically see the parts. So again, here's what I was saying with mixture being homogeneous or heterogeneous. A heterogeneous mixture, like this picture on the screen, this is what we call a density tower, which I'll get more into in Unit 2. A density tower with the most dense liquid on the bottom and the least less dense liquid on the top. There's different ways you can separate mixtures. You can magnetize and use magnets to separate. You can filter. You can use flotation if they have different densities. You can boil off one substance from another if there's different boiling points, but it's all physical means. So here's some practice for you, so you can pause the video and see if you get the answer right. And that's the end of the slide. So I hope you enjoyed Chapter 1 review, and I will see you in class.